All right, this is the section 3.3 notes that we would have done in class over lines. The objectives for this section are to learn the point slope and slope intercept formulas, and our final answers usually will either be written in slope intercept or general format when we write equations. We're going to learn how to write equations of lines if we're given certain conditions, graph using the slope intercept method, and some application of linear equations. So the first thing is the formula for point slope. This is a good formula to start off with if we are trying to find an equation of a line, and it requires two things, just as the name would suggest, a point and a slope. So to find those pieces of information, sometimes you'll be given them just directly, or you might have to, look at what information was provided and see if you can use maybe slope formula to find your slope. So if you're given 2 points, you could use the slope formula. And remember, the slope formula was given to us in the pre-video as m equals y2 minus y1 over x2 minus x1, which a lot of people have learned as rise over run. So this is really derived from that. They actually just multiplied the denominator to the other side, and they're calling the x2 and the y2 your x and y variable. So you plug in x1, y1 for those two positions and your m. So we use this one to kind of get us started. Now, usually we'll put our answer into a final format of either slope intercept or standard form, sometimes called general form, depending on the textbook. This textbook calls it general form. So slope intercept is when you solve your equation for y. So y equals mx plus b. And m is going, if you solve for y, m is going to be in front of x, and that represents your slope. And b is the y-intercept. It's very specific that it is the y-intercept, not the x-intercept. So you have to make sure you get that correct when you're graphing it. General form is a little different. You put your x and y on the same side together, and you have a constant on the right side. And it's just a different format of writing your answer. This is a good format if you're trying to do x and y intercepts. It's really easy to find those. Some key things, though, about general form is that no fractions are allowed. And generally, we keep the a greater than 0. We keep it positive. That is not always a requirement in every single textbook, but it is one that is a standard kind of set of restrictions. But the fractions is definitely required. You cannot have fractions in general form. It's okay to have fractions in slope intercept form. So the steps that we're going to be going through to find equations of lines, the first thing is if we're given two ordered pairs, we'll use the slope formula above that I wrote to find it. So we have to find our slope. If you're given a graph, you can count the rise and run to find your slope. Remember, positive slopes increase uphill kind of from left to right. Negative slopes will look like they're decreasing from left to right. If you're given an equation, you can always solve it for y equals mx plus b and find the slope as the coefficient in front of the x. So there's three different ways, depending on what you're given, to find your slope. To write your equation, you're going to use our point slope formula. So you're going to find slope, which we've already talked about. You're going to use your point and slope in the point slope formula. You could also plug m and a point into the y equals mx plus b and solve for b. That's also acceptable. We just don't focus on that as much in this class because in future classes, point slope and knowing how to plug into a generic formula like that is a very helpful skill. But you can use the y equals mx plus b to find your b as well. So solve for either slope intercept or general form based on the desired format. We're not going to be doing parallel and perpendicular lines. It used to be in the course. I have struck it out since this was an older document, so don't worry about that part. Okay, now we will talk about at least this. I will at least tell you what parallel and perpendicular is because the first question is not really requiring much information except knowing what it looks like. Parallel lines have the same slope and perpendicular lines have opposite reciprocals. So if your slope is -5/1, the parallel slope would also be -5/1. The perpendicular slope would be +1/5. So you flip it and change the sign. But that is just so you kind of have an idea. Parallel lines run across from each other like as if they're never going to cross, and perpendiculars cross at 90 degrees. So just knowing that, and this one point right here, so -4, +2, that's A. When we look at this, if we want to be parallel to the x-axis, that means we want to run across horizontally. So imagine drawing a line this way. parallel to the x-axis. That means my line would be y equals 2. It would have to keep that height of that point. If I want to be perpendicular to the x-axis, that means I want my line to run down and cross at 90 degrees. So that would be x equals -4. So remember, horizontal and perpendicular, so I don't want to say perpendicular, horizontal and vertical lines, sorry. They are always one variable equal to a number. So anytime you have a horizontal line, it's going to be y equals a number. Anytime you have a vertical line, it's going to be x equals the number that we're at on the x-axis. Okay, so let's look at part B. We're going to take this point and we're going to use the slope provided, and we're going to find the equation. And our final answer should be, in reading our directions, general form. So find the general form. So x and y both on the same side. So what I know is that I can plug this into point slope. So that would be y minus the y value, which is -2, equals m, which is 5, times x minus the x value. Now I already know that this is the y-intercept and the m, so I could have directly plugged into y equals mx plus b. And if I was going to slope-intercept form, that probably would have been my method. But we're going to general form. So if we distribute, that's just going to be 5x times, and then 5x times 0 is 0. So we got to get y and x on the same side. It doesn't matter which one you move. So I'm going to just move the y over since my x is already positive. You can swap the sides if you want, as long as you do that to both sides and swap everything. So this would be the general form of that equation. Okay, another one we're going to do for general form. We're going to look at, this is a x-intercept, so that would be 5, 0. So x-intercept at 5. So we need our slope. So 0 minus 6 is y2 minus y1 over 5 minus -1. And it doesn't matter if you do 6 minus 0, as long as you also do -1 minus 5 on the bottom. So I just want to be clear that you can do it either direction. But this is going to be +1, so that's going to be +6. So this is a slope of -1. Then I'm going to use my slope-intercept point slope formula. So y minus y1 equals m parentheses x minus x1. So and I'm going to pick this point. You could use -1/6 if you want. It doesn't matter as long as you just use one point. So y minus 0 equals -1 parentheses x minus 5. Go ahead and distribute that. Add the x over because, again, I want my answer in general form. So x plus y equals 5. Okay, skipping over the next two because parallel and perpendicular are no longer covered in the course. Find the slope-intercept form of the line that satisfies the given conditions. So this time we're doing y equals mx plus b for our final answer because they said slope-intercept. So to write these, this would be a -5, 0 for the x-intercept. The y-intercept is -1, so that would be 0, -1. Find the slope. -1 minus 0 over 0 minus -5. That's going to be -1 over +5 because it's minus a negative. And then I already know my b. So if you have your y-intercept, remember this is b. So we already know b. So if you have slope and you have the y-intercept, you can directly plug it into mx plus b. You do not have to do any point slope. If you don't feel comfortable doing that, you can do point slope and it should solve to this when you solve for y. For part B though, we don't know the slope, so we're going to plug it into our formula. So 7 minus 1 over 3 minus a -2. So that's going to be 6 over 5 because that's going to be 3 plus 2. Doesn't matter which point you pick, but I'm going to use the 3 and the 7. I like it when my numbers are positive. So y minus 7 equals 6/5 x minus 3, plugging into point slope. Now, when you encounter one that has a fraction in front of your point slope formula, one trick to get rid of that is to multiply both sides by that denominator. And what that'll do is that'll clear out the denominator before you need to distribute it. You can distribute if you want, but you don't have to do it that way because that's just going to create more fractions that you're going to have to get common denominators for. So if you multiply both sides of your equation by your denominator that's in your slope, you can clear that out before distributing. Now I'm going to distribute the 5 on this side, and a positive 6 is still left to distribute on the right side. We will be solving for y since we're doing slope-intercept form, so I'm going to add the 35 over. So that would be 35 and then a minus 18, which comes out to 17, positive. Then I need to divide everything in the equation by 5 to get y by itself. So my solution for this one is y equals 6/5 x plus 17/5. And that's okay because we're in slope-intercept. You cannot have the fractions, though, in general form. We will not be doing the next example because that is perpendicular bisector. Again, that has to do with perpendicular. Okay, so we've practiced finding slope. We've practiced writing equations. The next big thing is, can we use slope-intercept form to help us graph? So what we're going to do here is anytime you're graphing by slope-intercept form, first of all, you have to have a linear equation. That means you have to have a 1 for your x and a 1 for your y in terms of your exponents. You cannot have like a squared or on anything, or it wouldn't be linear. You're going to try to isolate your y. So I'm going to actually add that over to this side and subtract the 7x over. So I added 4y to the left, I subtracted 7x to the right. I'm going to divide everything by 4, trying to get this into slope-intercept form. And now we have it. So my b, which is my y-intercept, is at 0, -2. My slope is in front of my x. That's at -7/4. That can mean one of two things. You can either go down 7 and then write 4 using the negative on top, or you could rewrite that with the negative on the bottom and go up 7, but then go left 4. So the negative can only do one thing. It can either make you go down or it can make you go left, and that just depends on if you put it on top or bottom. But the positive numbers are always directions are up and right. So you are, remember, rising, which means up or down on top, and running, which means left or right. So make sure you get those directions correct. So we plot the y-intercept first, and this will be the same thing when you're doing your WebAssign. You'll be looking for the tool on the side that has the 2 line arrows. You always want to plot and click this first. So this is the tool you're needing. And then you want to plot that point on the y-axis, that y-intercept, and then you'll click it so that it actually plots the point. And then you'll rise and run however you need to, and then click on your second point. You do not want to add a third point anywhere because that will confuse it to when it's reading the algorithmic part and saying, is this equation correct? It will see 2 separate answers if you do it with an extra point separate from your line. So you have to be using the tool that says line. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, then write 1, 2, 3, 4. Put a point there. I'm also going to show you that I could have gone 1, 2, 3, 4, 5, 6, 7 up, and then left 1, 2, 3, 4. If you've done everything correctly, those should be all in a line together, but WebAssign will only need you to pick a second point. So just one direction correctly done from your y-intercept. Okay, let's look at part B. This one we need to again solve for y. So I'm going to subtract the x over. I'm going to divide everything by -5, being careful that I am dividing by a negative. Negative over negative is going to be positive, so that's going to be 1/5 x plus 3. So my y-intercept is 0, 3, and I'm going up 1 and right 5. So positive 3 on the y-axis, up 1, right 1, 2, 3, 4, 5. And again, if I was using WebAssign, the tool would have made that line for me. Okay, this is the last piece of 3.3 before I do the 3.4 video. It says mathematical modeling using linear relationships can be modeled in an equation form of y equals ax plus b. A is just, remember, like our slope. They're just trying to give this a generic name. For our purposes, we're usually, these are descriptions that will be either graphs or equations if they're given to us. So you have to have something in the problem that says assume it's linear, or this is a linear relationship, before you can just write a linear equation. So it says a baby weighs 10 pounds at birth. At 3 years later, the child's weight is 30 pounds. Assume that the childhood weight is linearly related to age in years. So we have to first of all get our ordered pair correct. And when they say is linearly related, usually this is y is related to x. So t is going to stand in as x and w is going to stand in as y. So I'm going to write that as an ordered pair so we get this correct. So you do have to follow the directions they give you in the problem. So whatever is linearly related to the other piece, the piece you're relating to is the x, because y is usually written in terms of x. So then for the first thing, we need some ordered pairs. So at birth, a baby is 10 pounds, the specific baby. So birth would be 0 years old, and the weight was 10 pounds. 3 years later, so now the baby is 3 years old, the child weighs 30 pounds. So that's enough for us to find our slope. So 30 minus 10 over 3 minus 0 is 20 over 3. And I'm going to leave it like that, just leave it in fraction form. I also already know my y-intercept because this is a 0 comma number, which means it's a y-intercept. So this is b. So I could either do point slope if I didn't catch that, or I can just go ahead and see that that's going to be my equation. So y is w equals 20/3 t plus 10. So the only reason I'm allowed to write plus 10 here is because I know it's the y-intercept, just by the way it looks. Again, if you need to do point slope and plug everything in and solve it, you would still get this at the end. So what is W on the child's 6th birthday? So how much does the child weigh when it's 6 years old? So 20 over 3 times 6 plus 10. 3 goes into 6 2 times. So this is 40 plus 10. So if this child actually is growing in a linear fashion, then that child will weigh 50 pounds on their 6th birthday. This last question says, at what age will the child weigh 70 pounds? Obviously, assuming we're finishing the same trend. So that would be weight is 70, and we're looking for time. I would subtract the 10 over first, multiply both sides by 3, and divide by 20. So it looks like the child will need to be 9 years old if this trend is to continue before it weighs 70 pounds. And usually people don't grow completely linear. If you've ever had kids or if you've seen people take their kids to the doctor, there's more of a curve to the growth chart. So this is just using this for an approximation purpose. All right, so that is end of 3.3. Like I said, this is not a super heavy section. 3.4 video is going to be recorded next, and I'm going to make these both into a playlist. And remember, you need to watch them both since we are canceling class on Thursday the 12th, okay?